Hello, and my name is John Sheffield. I am a professor of engineering technology at Purdue University in West Lafayette, Indiana, the United States. I also serve as the president of the International Association for Hydrogen Energy. It is my pleasure and honor today to share with you my insights on green hydrogen at the Global Clean Energy Summit 2024 in New Delhi, India. The title of my presentation is Green Hydrogen in the Race to Zero, a Global Technology Perspective. One might ask, what is green hydrogen? Well, green hydrogen is hydrogen produced by splitting water from electrolysis using excess renewable electricity. For many, including those in the oil and gas industry and large utilities and industries from steel to fertilizers, green hydrogen is regarded as the best bet for harmonizing the intermittence of renewable energy sources while decarbonizing the important industrial energy-intensive sectors such as industrial, chemical, and transportation sectors. If we look at the green hydrogen value chain, starting on the left, lower, we have the green box of green hydrogen produced by electrolysis of the excess wind or solar energy as an example. Otherwise, the wind and solar electricity power is fed to the utility grid. When we have that excess, we take water, electrolyze it, and produce a green hydrogen. At times, we may use that water for reformation of natural gas. And if we do the carbon capture, then we produce what is known as blue hydrogen. If we mix the blue and the green hydrogen together, we might refer to that as clean hydrogen. So the clean hydrogen is a potential of the traditional steam methane reforming, but with carbon capture and storage. Now, once we have the clean hydrogen, we can immediately use that on site for gas turbine power plants. So the value chain can be used of the clean hydrogen for internal combustion engines, again for producing power or mechanical power. The clean hydrogen can be injected into our natural gas distributions, enriching the caloric value as well as providing a cleaner gas mixture. It can be used to used in our refineries and petrochemical applications to help decarbonize those hard to industries that are hard to abate. The natural gas with the clean hydrogen then can be transported over some distance and then be used at remote locations for gas turbine power plants, the internal combustion engine power plants, the industrial and residential customers for their applications. What is the role of hydrogen in emission mitigation? The easiest way to see this in the landscape, as shown here by the artist rendering, is a carbon neutral value chain, sometimes referred to as power to X, where X can be one of many choices. If we start on the left, we see the green box of the green renewable power generation from solar and wind, hydro tide, geothermal, biomass, waste energy, and perhaps some might include nuclear. Once we have that green power, then we can go to low pressure electrolysis through the alkaline or PEM electrolyzers, or through high temperature electrolysis through the solid oxide process. The next in this through the distribution system is our storage and transportation of hydrogen. It can be done by ship, train, truck, and pipelines. In that, we can compress the hydrogen, we can liquefy, we can hydrogenate. In that, we can produce a synthetic fuel or a green hydrogen derivative, and probably the most important one is a green ammonia as an e-fuel. With that, we can then transport onto our green hydrogen utilization in natural gas grid enrichment in the power to X, as we see, in industries and the electric power generation through the various energy conversion devices, gas turbines, fuel cells, and combustion processes. I would like to share with you now an International Energy Agency, IEA, Global Hydrogen Review of 2023. And on the left, we can see the map of the announced low-emission hydrogen products that are used for production of our hydrogen. And the sizes of the symbols represent the scale as shown in the legend here. But it's important to see that the orange is the early stage, the gold is our feasibility studies, the blue is under construction, and green in operation. And then we can see a very European-centric at this time with the full mixture of green, blue, gold, and orange representation. But if we look at the feasibility studies, we see some new large systems coming in play in North Africa and other regions. If we then look at India, for example, we have a little bit of a centric and a mixture of the blue, gold, and orange stages of electrolyzer production. But if we go to South America, we see some large-scale early stage development and in some cases feasibility studies. And those tie in well to the critical minerals needed for the sustainable future with our energy transition. So Australia is similar in some of the large early stage developments. And I will talk about Australia as an example of a renewable energy supplier through the production of green hydrogen and its derivative green ammonia, and going to transporting that to, say, a city-state like Singapore. Now let's turn our attention to some more information, in this case from the World Economic Forum, a report that was published recently in 28th of November in 2023. It's a net zero industry tracker, the 2023 edition, the Insight Report, and you have the link, the URL at the bottom of this slide. And this report provides a detailed analysis of the progress of heavy industry transportation sectors are making worldwide in their efforts to achieve net zero emissions by our target of 2050. That is the race to zero. These sectors, which account for more than 40% of the global greenhouse gas emissions, need multifaceted solutions that accelerate the speed of technology development, build the supporting infrastructure, and raise the necessary capital to finance the transformations. Further in this report, we can see sort of deep dives or dig deeper in aviation industry, in the shipping industry, in the trucking industry. In addition to that, we have the implications on the steel industry, the cement, aluminum. These are all energy-intensive industries. In addition, perhaps the most significant are these last two. The ammonia industry, that if we can produce the green hydrogen from electrolysis of water, from excess renewable electricity, that green ammonia that we produce from the green hydrogen then can be used as a maritime shipping fuel. It can be transported by ships in large quantities across the globe. It can be decarbonizing the oil and gas industry, and already OPEC is making initial efforts, and Saudi Arabia has some of the largest projects on this way with solar and other cases global wind, both onshore and offshore. And offshore, the magnitude of the renewable energy, the opportunity for the excess renewable electricity for hydrogen production and transported directly from those offshore ports. So with that, there's an appendices that also provides a lot of detailed information. Now, as an example, I want to show you the total infrastructure investments by industry and by enablers by the target date in our Race to Zero to 2050. If we start at the top of the list, in the dark blue, I show you the clean hydrogen. And again, remember, clean hydrogen is a combination of our green hydrogen, and if we have the carbon capture and sequestering technology, the blue hydrogen. At this point, we can think of it as green hydrogen, and in aviation, the investment is in the clean hydrogen. To a lesser extent, it's in the biofuels. In shipping, the very large percent is in the investment of clean hydrogen. A very small amount in the CO2 transport and storage, and to some extent our biofuels. In the trucking, we see that the clean power, the clean electricity from that renewable energy in the electric drive on trucks, long haul and short haul. The clean hydrogen probably makes up the long haul or the very heavy duty, and some cases and some locations at a smaller scale in biofuels, biodiesel, to continue that process. In the steel industry, the clean power is the most significant, but is second, but very important, is clean hydrogen investment. In cement, it's in the less significant, but in the clean hydrogen as opposed to the clean power. Aluminum, it's clean electricity, the clean power, and to a smaller extent, clean hydrogen. And the third component is almost quite small. So in that, we see ammonia, the green hydrogen derivative, green ammonia, is a very large significant from our investment in the process for clean power. So with that, the oil and gas industry, hydrogen, whether is the investment for the hydrogen or the investment for the clean power or renewable energy. So whenever we see clean power in this, think of renewable electricity. As I mentioned earlier, I wanted to talk about Singapore's national hydrogen strategy. Singapore is at the inflection point in global hydrogen development. Global developments in hydrogen are at an inflection point, with increased investment from countries and companies globally to develop new technologies and establish supply chains for clean hydrogen. Singapore believes that clean hydrogen has the potential to be a major decarbonization pathway to support Singapore's accelerated transition towards net zero by 2050. So they are fully embracing the race to zero. Now, Singapore has an important role in the sense that it is a major port. And I'll speak to that in more detail later. Singapore plans to build a capacity to import, handle, and utilize green ammonia as a hydrogen carrier or directly as a fuel in power generation in the ports of Singapore and for the city itself. The ammonia supply chain development will also supply maritime bunkering needs. So the dark green arrows represent the ammonia pipelines and the lighter green is the hydrogen pipelines. So as we receive tankers bringing in the green ammonia from overseas sources, potentially as an example, a logistic supply chain would be from excess renewable energy in Australia, producing the green hydrogen, transforming that to green ammonia, using that to bring it in as a green ammonia in tankers, as well as being used as a maritime fuel. And the supply chain process are shown symbolically in this schematic diagram. Now, why is Singapore so important? And why is the port of Singapore important? Well, it's currently the world's busiest container transshipment port in the world, with ship arrivals tonnage exceeding 2.8 billion gross tons in 2021. Singapore is also the largest bunkering hub, supplying close to 50 million tons of maritime bunker fuel to vessels using the international shipping routes in 2021. As a major global maritime hub, Singapore can play a very important role in decarbonizing, especially through the transitions. To this end, the Maritime Singapore Decarbonization Blueprint has been released. I was in Singapore last year at the end of the year, and Singapore is already transforming their existing 4 ports into one megaport. They have one port already decommissioned and in that transformation. Singapore plans to focus on decarbonizing port operations and transitioning to domestic harbor craft towards full electric propulsion or net zero fuels such as green ammonia. By 2050, container handling operations will be electrified, supplemented by low-carbon energy sources such as hydrogen. They envision this all in achieving the net zero emissions by 2050. The international maritime sector is undergoing a green transition that will span the next few decades. Engine manufacturers have made progress in developing engines that can directly burn green hydrogen derivatives, such as green ammonia, and large global shipping lines have already ordered new fleets built to run off of these green ammonia engines. These developments are reflected in the latest industrial projections. So Singapore gives us a blueprint. It gives us a vision of the transition that we will see. I think it would be wise for India to pay close attention to these developments that are occurring in Singapore. Now, another aspect is civil aviation. And Singapore, again, has one of the most impressive airport distributions, and sustainability will be key priority for Singapore aviation sector in reviving their air travel and rebuilds their Singapore air hub. Their airlines is recognized as one of the leaders. So this airplane, the hydrogen-powered clean energy of the future, one of the concept planes of Airbus, one of 3 for these long-haul flights. Now I'd like to give you an even broader perspective from the Hydrogen Council. This is a report that was issued on October 18th, 2023. The Hydrogen Council is probably the leading authority in hydrogen. They are an organization led only by the CEOs of corporations, and these corporations are a major powerhouse in the global economy. And their strategy is to look at hydrogen and decarbonizing energy systems. To put this in a perspective that people can visualize very easily is to look at, on the top, the Sankey diagram. The Sankey diagram looks at the inputs and compares to the outputs and the sector coupling of those inputs and into the outputs. Today's energy system, little interconnect between energy vectors. So the energy vector is going from left to right. There is no or virtually no sector coupling. Yes, there is some oil used for electric generation, but it's at a high cost, and it tends to be at remote locations. But the oil then becomes a cost for those. Yes, there is some biomass used for electricity, but that's not really the sustainable future that will drive the electric power of the future and the decarbonation and the sustainability. So let's start at the top Sankey diagram, and the top of that Sankey diagram is oil. Oil, for most part, is used as a liquid fuel with heavy emissions, heavy production because of that fuel oil. Small amounts are going into cross-acting electric, and that's really one of 3 sector couplings that's shown here. Next, we go to natural gas in the oil and gas sector, and more than or approximately half of natural gas is used as a gaseous fuel. Some of it is used for electricity, but not often for baseload, but rather for peaking and demand response in peak seasons. The renewables are used primarily for electricity and don't have a sector coupling at this time of notable scale. Biomass is some amount is used for electricity, but it's an ineffective mode of operation. So it's used as a fuel and it has emissions. And coal is sort of the other component of the heavy emissions that we would like to diminish. And the coal then is used in electric power. The example that's unfortunately is continuing to grow is in the case of China. China continues to build a new coal plant every week. Yes, China does produce renewable energies, but at the same time they have a growth of that. So they have a growth in both industries, and they're not reaching towards a decarbonization or a race to zero to 2050. Far from it. So coal is used as a solid fuel, and in previous centuries it might have been used as heat. We recognize that as again one of the catastrophic results of pollution. If we look at the future energy systems to enable the intercoupling, so we have a dramatically decreased oil, not to zero, and in that we use the oil for liquid fuels. In the natural gas, we have a larger share of the low carbon hydrogen blending, the power to X, as we talked about earlier. And we also have that going into gaseous fuels, and we might have a carbon capture and sequester. Now we have the natural gas going into the renewable energies. The power to X is an example, and the renewables can be used replacing the natural gas and coal, becoming the large drivers in electrification. And the growth of electrification is important to recognize that the largest vector is electricity. That's the electrification. That's the way we do the decarbonization. We do increase the amount of biomass into the production of electricity, and unfortunately in some locations we still might have the use of both biomass and coal for solid fuels. And in those countries such as China, they may not achieve their net zero into well past 2065 or beyond. See. With that, I want to thank you again for your attention, allowing me to present my insights on green hydrogen and the roles for a sustainable future. I'd like to share with you my coordinates. At Purdue University, professor of engineering technology. My email address is jsheffie@purdue.edu. That's jsheffie@purdue.edu. I'm president of the International Association for Hydrogen Energy and also the senior associate editor of the International Journal of Hydrogen Energy. It is a point of reference. In 2023, we published 100 issues of the journal with more than 40,000 pages of hydrogen papers. And India was a major contributor to both the production of those authors as well as readers and reviewers. So we thank all of those researchers and scientists and engineers active in the green hydrogen industry. Thank you once again. All the best.